Howdy, this is a podcast on synthesis and decomposition reactions. You'll want to have out your blue sheet because that's the only way you're going to know some of these because you don't memorize them. I'll give you this template on a test, but you have to understand what all this verbiage is, and it refers back to, especially this stuff here, the pink sheet, and you have to know how to use the periodic table and write compound formulas. So let's start on worksheet 2. Hopefully you have that around somewhere. If not, it doesn't really matter. And I'm going to start with number 2 on worksheet 2, and it's Mg plus N2. Now I can tell that this is a synthesis reaction because I have 2 individual elements with a plus sign. And a synthesis is where 2 things become one. Now I look at my synthesis rules. Is it a non-metal oxide plus water? Clue is there's no plus water. It can't be that rule. The next rule says metal oxide plus water. There's no water. It can't be that rule. It must be this last rule. Metal plus a non-metal makes a salt. So how I do a lot of these is I eliminate what it isn't, and then I go with what I think it is, and I may not be right, but I may be. But we'll give it a whirly-McGig try. So Mg plus N2 makes a salt. A salt is always a cation, and Mg is a 2 plus and an anion. And the anion here is N2, but you don't carry that 2 over. That 2 is just there because it's a diatomic gas, but on this side it actually could change into something else, like a liquid or a solid, and that nitrogen is a 3 minus. So now we have to combine this in the proper ratio so that their charge is balanced. So if there's a 3 there, the 3 most likely is going to go there, and that 2 there means that I'm going to put a 2 there. So I'm going to have Mg3N2. Now, the trickery-dickory-dock thing is that you have to balance this whole equation. I can't seem to erase these 2 numbers here, so I'm just going to cross them out because it is not correct to have them in your final answer. So now we have to balance the final equation, and I'm just going to look. I have 1 Mg and 3 Mgs, and I have 2 Ns and 2 Ns. My Ns are balanced, so I just need a 3 in front, and then that one's balanced. Let's try number 7. 7 is Ag plus O2. Okay, now this, again, is a synthesis, and it doesn't follow either of those first 2 rules, A or B, because there's no plus water in there, so it must be this again. So we put Ag and O together. We look at the charges. O is a 2 minus. Ag is a 1 plus, so we got to crisscross our charges. We need a 2 there and a 1 on the O, but we don't write that 1 on the O. And then you got to erase these, and my eraser doesn't work on here so well. And then you'd have to balance the whole thing, and you would do inspection 1 Ag, 2 Ags, 2 O, 1 O. I think I'll start by putting a 2 there, so I have 2 O's. Now I have 4 Ags, so I'm going to put a 4 in front there. Let's try number 10. Number 10 is, it's a 10, believe it or not. Number 10 is Na2O, Na2O plus H2O. So this is one of those water ones. So let's look. Is it the first one, non-metal oxide plus water? Non-metal oxide means the first element's a non-metal. Well, sodium's a metal, so it can't be rule A. Rule B, metal oxide plus water. Is that a metal? It is a metal. So it's this, so I follow what it says. It makes a metal hydroxide. I have to know what a hydroxide is. A hydroxide is OH. I like to keep it in parentheses unless I'm doing Webassign. OH is a 1 minus. And it has to be a metal hydroxide, so where's my metal? There's my metal. So it makes Na. Na is a plus, and I really just need 1 of each one, so it looks a little better written like NaOH. And then you have to balance it. 2 Nas, 2 Nas. Sorry, can't count so well. 2 Nas, 1 Na. 2 O's, 1 O. 2 H's, 1 H. I think I might just need a 2 in front of that thing. And let's double check. 2 Nas, 2 Nas, 2 O's. Now I have 2 O's, 2 H's, 2 H's. It's balanced. Let's try number 15 at the bottom. Number 15 is H2O plus K2O plus K2O. Now I switched this one up on purpose to see if you would notice it still is one of these rules with water, and you have to figure out which one it is. It doesn't matter which side of the plus sign the compound is on. It does matter which side of the yield or arrow sign it is on. So I switched this one up on purpose to see if you'd catch that. And we have a metal oxide because K is a metal. So again, we make a metal hydroxide. The metal has to go first. And the metal for this one is K. And the hydroxide is OH. And if we were to look at the charges of those, that's a 1 plus and that's a minus. So you need just one of each of those, which is more than fine. I really want my large eraser. Erase-me. There we go. Now we have to balance it. 2 H's, 1 H. Actually, my eyeball's drawn to the K's. 2 K's, 1 K. Let's start with that. So now we have 2 K's. Is it done? 2K, 2K, 2 O's, 1, 2 O's, 2 H's, 2 H's. That's called speed balancing. It's awesome. Now let's work or move on to the decomposition part. And I'm going to start with Rule 2A, and I'm going to pick number 19 for that. 19. 19 says CaCO3. So that is a carbonate. How do I know that's carbonate? You just have to know that on the pink sheet, CO3 is a carbonate, or be able to look it up. And so the rule says a carbonate yields a metal oxide plus CO2. You get a freebie in there, and that's the CO2. That's a beautiful arrow. So at least write your CO2 and get some points. Now you have to fill in this blank with the metal oxide. You have to figure out what that is. The metal. There's only one metal here. It's Ca. So you write in Ca. And in your head, you know Ca is a 2 plus. And then oxide, because it says a metal oxide. Oxide is oxygen. Oxygen's a 2 minus. Those are quite happy as a 1-to-1 ratio, so it's just CaO. And I believe this one is balanced. Let's give it a checkaroo. 1 Ca, 1 Ca, 1 C, 1 C, 1, 2, 3 O's, 3 O's. It's balanced. Ching, ching. Now let's move on to the second one on here, a hydroxide. And I'm going to choose kind of a hard one, which is number 27. Who doesn't like that number? That's 3 cubed. And it's FeOH2. Now the rule says hydroxides break down into metal oxides plus water. Again, write down your freebie plus the water. And it says a metal oxide, the same thing as last time. So there's my metal, Fe. Oh boy. Fe is one of those transition metals. I have no idea what the charge is. It could be a couple things. So what you want to do is check here, and Fe is most likely a 2 plus. If that's a 1 minus, and there are 2 of those, one of these must be a 2 plus. So in your head, Fe is a 2 plus. There's your head up there. Isn't that nice? And the oxide again is oxygen. Oxygen never changes its charge, at least this semester. And they are good as a 1 and a 1. And so that's your final answer. And I believe it's balanced. It is. Ching, ching. Now let's move on to the chlorate rule. And I'm going to choose number 20 for this one. And number 20 is KClO3. And it decomposes, the rule says, into a metal chloride plus oxygen. Well, at least get your oxygen free point in there, for heaven's sakes. And a metal chloride. The metal is the first element written there, K. Chloride is Cl, chlorine from the periodic table. That's a 1 minus and that's a 1 plus. So you have to make sure they balance, and they do. It's KCl. And then you have to make sure that your whole thing is balanced. 1K, 1K. 1Cl, 1Cl. Oh dear. 3 O's, 2 O's. When I see 3 and 2, I always think of 6. So I need a 3 there to make that 6, a 2 there to make 6 O's, and then a 2 there to make 2 K's and Cl's. Now I'm going to balance an acid, and the acid is right here. The acid is the hard one, just as the acid with the synthesis one was a hard one. And the rule says it makes a metal oxide, a non-metal oxide plus water. So I'm going to at least write my water down there and get that free. And the non-metal is C, and the oxide is oxygen. And this is where I get to choose how many I have of each one. It's the only time you get to do that. Since they are 2 nonmetals together, you can't look at charges to figure out how many you have of each. So I cheat a little bit. I see that I have 1 C, so I want to keep that as 1. And over here I see I have 3 O's. And on this side I have 1, 2, If I were to make that a 2, now I would have 3 O's and it would be balanced. I'm just going to leave it at that. Now I'm going to do the rule about metal oxides, which is 2E, and I'm going to choose number 26. That is Ag2O. So that is a metal oxide. There's metal, there's oxygen. Really and truly, when you see two elements together, just split them up. So you could split them up into Ag and O. Can you leave O like that? No, you can't. It's one of those diatomics. It has to be O2. What are the diatomics? H, NOF, excuse me, got my C on the wrong place, Cla, Brie. Remember that from the periodic table? It looks a little bit like a pop gun. There you go. Ag does not have a subscript 2 because it is not one of those diatomics, but now you have to balance it. I have 2 here, so I'm going to put a 2 there. Oh, rats, I messed it up. I actually have 2 O's, so I need a 2 over here. So now I have 2 times 2 of the Ags, which is 4, and I have 4 Ags. I'm going to do one more, which is the electricity. Electricity and the ionic compound actually go together. Sometimes they don't, but in general they do, and I'm going to choose number 24. And 24 is NaCl, NaCl, sodium chloride, via electricity. I like to use my little thunderbolt for electricity. And the rule says possible heat or some other input energy splits it into its parts. Well, let's look at the ionic one. It breaks it up into its 2 parts. Duh. So in the Na part, it does not have a subscript 2 because it's not diatomic, plus Cl. Cl is one of our NOF ones, so it does have a subscript 2. You need a 2 there and then a 2 there. So if you have 2 Cl's, you can make 2 Nas and 1 chlorine diatomic gas. I hope this little screencast on synthesis and decomposition was helpful a tiny bit. Actually, I hope it was helpful a lot, but you never know. Till next time, ciao.